All right. Quotient, identities. You have tangent x equal to sine x over cosine. Cotan x equal to cosine over sine. It's the first set right here. Okay. Pythagorean. These are the ones that I showed you how to derive them briefly. There's 9 of them. They all come from this guy. So sine squared plus cosine is equal to 1. So that's the OG right there. You move things around, you create 2 more. Just doing some algebra. Divide by cosine, and you'll get this guy. Cosine squared. Subtract secant, or subtract the 1, and then subtract what's it called? Tangent. Divide by sine, you get these guys. Okay. If you can, when you get a moment, I would say put every single formula that we've talked about just on one big page. I'll try to send you one that has what's it called? Has most of them. But I think it'd be better to just write them yourself because you'll know exactly what you've been using. Okay. These are pretty important. Use these the most, I think. Okay. The cofunction, I don't really use those much at all, but it is good to understand when you're like looking at graphs that if you shift one of them, it turns into the other. So sine of pi over 2 minus x is equal to cosine. And if you shift tangent by pi over 2, like this, you get cotan. If you shift cosine, you get sine. And cotan can go the other way too. All right. Almost done. Now the last one would be the even and odd properties. So everything is odd except cosine and secant, but secant is just a reciprocal of cosine, so it's really just cosine. Everything else is odd. Okay. So sine of negative x is equal to negative sine. Cosecant of negative x is equal to negative cosecant. Tangent of negative x is equal to negative tan. You all remember what even and odd functions are from college algebra. So all of these are odd right here. Okay. All right. And these are the even. So basically even means if you plug in the negative angle, it's as if you plugged in a positive angle. It's the same thing. Okay. If you were to plug into an odd function, plugging a negative angle is the same as plugging in a positive, but you multiply the entire result by a negative. Okay. That's what you can do with odd. I don't have enough space here. We'll do. I'll write on the next page. Let me find some pictures. Okay. So we know that x squared is even, right? So what that meant back in the day, if you plugged in a 2, maybe I should use f of x. Plug in a 2 into the function f, I get 2 squared, right? Now, if I were to use a negative 2, you see how I get the same result here, right? So it doesn't matter because it's even, positive or negative, you're going to yield the same result. So it's as if you use the positive, if you plug in the negative. So that's what that notation is saying. So cosine, if you plug in a negative angle, you can just switch to a positive angle. Sorry, one second. Right. So odd function. So we should know that the cubic function is odd, right? Call this G. Let me turn this one off. Okay. Now, if you plug in negative, let's say negative 2 versus 2, they're going to be the opposite sign. That's what this is saying. It says if you multiply the result by a negative. So you can plug in the positive version and then just swap it by putting in a negative. Does that make sense? What odd means? I feel like even might be. Is even clear? Just reminding you from college algebra, which is okay. So let me know if you have any questions about even or odd. Okay. You guys cool on this page? All right. So let me know. I'm gonna try back. Okay. All right. So just the definition, just real quick. Even means this for any function that is even, and odd means this. Now I'm going to move on. This is the definition. If this happens to your function, then it is even. This happens and it is odd. It could also be neither. And it's not always depending on the power or whatever. It's depending on this. This is the definition. Okay. Let's move on to example 1. Problem, I think this is 9. Let me check. Let me open up the homework. There it is. Okay. So first, they're going to test you on the identities and properties I gave you. So let's move on from that. Same thing for number 4. They're testing, okay, if you were to multiply this out and reduce it using your properties, what does it turn into? That might be worth doing. Do problem 5. So you can see what they want us to do. So they want us to basically simplify the question. So if you have cosine x times 1 plus tan squared, what does that become? All right, so I'm going to write that on the paper. Okay, so simplify this. What is 1 plus tangent squared? My camera today. There's too much garbage on my desk. On my to-do list, buy a bigger desk. One plus tan squared. Let's see here. Here. 1 plus tangent squared is secant squared, right? So we're going to be referring to this page in order to solve these. So 1 plus tangent is actually secant. So from here to here, we use the Pythagorean. Now, secant is actually, as a reciprocal, what is secant? Secant is 1 over cosine, right? But since it is squared, it would be 1 over cosine squared. So these will reduce. I'll show an extra step just in case. So from here to here, that was a reciprocal property or identity. Now we just do some algebra, which gives us cosine, or actually 1 over cosine, which is secant. On these types of questions, that's what I want to see, like on the exam. Like picking the answer D is not sufficient. Right, so you start with this and make your way to secant. Okay, does that make sense? Any questions on 5? Okay. I'll let you do number 6. Let's do number 9 together. Okay. Here to here was just algebra. Here to here. Actually, the whole thing was, these 2 lines are just algebra. Then reciprocal. I'm gonna write down every single identity that I use along the way. Okay. Number 9. The instructions are basically to simplify as far as you can. So this time they're not telling you what the answer choice is. You just got to use all your identities until it's as simple as possible. So we start right here. Okay. So there's two ways you can think of this. You can think of tangent and cotan in terms of reciprocals, or you can think of them as ratios or quotients. You know that tan is equal to 1 over cotan, correct? the reciprocal identity, which means that at the top you have a reciprocal being multiplied. When you multiply two reciprocals, they always cancel, right? If you have, for example, 2 times a half, that's a 1. This is basically the same thing. This is like your 2, and that's like your 1/2. They're reciprocals, therefore they cancel. So we can show the work and say, well, you know what, this is the same as 1/10 all over secant. So these will cancel. So now you get to here, which is 1/secant. And then you have to remember, okay, well, 1/secant is equal to cosine, right? That's another reciprocal identity. Right, from the first page. So that becomes cosine. So that's as simple as it gets when you simplify, right? You can get all the way down. There's nothing else to do. Is there any questions on what they're asking and what we did? Okay. So let me know. So your homework is going to be based or chapter 7 exam questions, and I guess this section for sure. It's going to be just stuff like that. We're not actually solving for anything. We are applying identities, simplifying questions, or proving a statement. That's all we are doing. For example, I guess we'll get there in a second, but as you can see, like, we're not solving anything. It's just simplify as far as you can. Does that make sense? Let's do problem 10, I guess. You guys cool on the other page? So tangent squared minus tangent squared sine squared. So in my opinion, the hardest part of this section is going to be how good are your algebra skills. If your algebra is garbage, then this section will be really difficult, this chapter. Also, your fraction skills are going to be really important. Okay. So all the factoring and fraction steps that you have done before is going to be assumed that you know it here. So if you've forgotten something or you don't see it, let me know. No, I'll refresh you. Okay. Just tell me. Okay. So same thing, but we got to use algebra to help us out. Reduce as far as you can. Simplify the question. We have a tangent in common, so that should be a hint that you should try factoring and see what happens. Okay. So the hardest part is just learning what to do, or to how to start, I guess. Because there's no like, it's not the same every single time. Okay. You just have to try something. Um, what you try might be wrong, so you try something else. But my first instinct was, okay, there's a tangent in common. Let me try factoring. See what happens. Okay, so it's not going to tell you how to start. You need to be able to figure that out. And that's the hardest part. So as you practice this, you'll see, like, okay, if I see two fractions, maybe I should try adding them together, see if something pops up that I can use from my formula sheet. Okay, so that's the goal. You're trying to get somewhere and apply your formula sheets. All right, your identities, I guess. So as soon as I factored, you should see that 1 minus sine squared should be glaring at you. Right, that's one of the identities. Right, what is 1 minus sine squared equal to? From your page. Yeah, it's going to be cosine. So let's just try and change it, see if that helps. It looks a little more simplified, right? Less complex. So maybe that's good. Then we have to remember, so right here we did Pythagorean. Tan squared, cosine squared. So when I see this, I think, okay, well, maybe I should change tangent, because that is a ratio, a quotient. So we should change this and see if that helps us. So that was quotient. So now, is it obvious that these will cancel? You see how once we change it, it becomes a little more clear. There's not, and again, there's different paths that you can take. There's sometimes a shorter path, but when you start doing a bunch of these, you're going to see, okay, some paths are extremely long and we're probably not efficient, but they might work. So at this point, it says, simple as we can make it. Doing anything else would make it more complicated, so it wouldn't be simple or simplified. Is there any questions on any of these steps here? Does that make sense? Is it, you see what I'm saying? 1 second. Okay, so you guys are cool on that question. Let's look at another one. This time, maybe you can decide what you think is difficult. So this is what we did, number 10. So as you can see, it's the same type of stuff over and over again. Let me see if there's anything I should delete, actually. No, they're all whatever. So, is there any of these would you like to try out together? All right, let's do 12 first. 20, what is that? Yeah, 20 is 20 is interesting. Sure. We'll do 12 first though. Okay, so 12, they tell us the answer is going to be sine to the fourth. Okay. So, I mean, we're not going to know that when you're not going to know that on your homework, but it helps to know where we're going, I suppose. But let's pretend we didn't see that. I don't think it's all that helpful anyway. At least not for this one. Problem 12. One minus 2 cosine squared x plus cosine to the fourth x. Okay. I have no idea how to start that yet. Let me think about this. And every time I move a little bit, blurs out. Okay, so we need to simplify this. Cosine squared. It looks like you maybe factor this. Or we can change let me double check that I wrote it correctly. 1 second. Plus, minus, minus 2. Okay. Well, again, like I said, let's just try stuff, see what happens. I know that this is going to be cosine squared squared. I can change this inside part into a sine and see if that helps me. So let's see. So do you agree that cosine squared is equal to 1 minus sine squared? Right? Yeah, that's true. We could factor cosine squared. Let's try that, Raymond. I like that idea. Remember, the idea is to try something. See what happens. Don't get intimidated. Don't just stare at it. Just try something. Okay. So this was factored out. Cosine squared. Let's change that one because I see a 2 here. Like maybe I can do something with the 2 when I change this to sine. So 1 minus cosine squared times this garbage. This will be 1 minus sine squared x. Is that helpful? I don't think so. That would be a 3. This is an interesting one. Oh, you're good, man. Let's see here. This 2, it's messing me up a little bit. Here, I don't know if factoring is going to help us. We do have a trinomial. We might be able to factor that as well. Let me try something on the side here before we start over. Let's let W equal cosine. So you got 1 minus 2W squared plus W to the 4th. Okay. I'm going to do a double substitution just to make it pretty. So that'll give us U squared minus 2U plus 1, which factors into U minus 1 times U minus 1 It's my scratch work over here, which would be U minus 1 squared, right? Do you agree with this factoring here? So U is actually W squared, but W is actually cosine. So this is really cosine squared. Yeah, I think this path might be better. Let me show the steps though. Yeah, here we go. So we'll do it this way. So let me do that over here. Let's start over. It looks like factoring the trinomial might be better. Okay. All right. So if I rewrite this so you can see it better, because I know this might be kind of weird on the right here. The idea is to factor this trinomial. Now, if we let W equal cosine, it's more of the type of stuff that you've seen before. Right? We've done these types of factorizations a bunch of times, right? Okay. So you should know that this is a quadratic type. So doing the trinomial, you end up getting W squared minus 1 times W squared minus 1. Okay. Which is really W squared minus 1 squared. but W just a dummy variable just to make it look a little prettier. Makes no difference. So at that point, you bring cosine back. But cosine minus 1 is the same as oh man, I'm trying to keep it simple for you guys, and I don't think I can. It's gonna be weird no matter what I do. Oh well. Do you agree that if you square a negative, it becomes positive, right? So check this out. If I were to factor a negative from the inside, I would get this, correct? So then if I square it, it's going to become positive anyway. So you can actually adjust this to fit our formula. Does that make sense? This is the weird part. So then that becomes sine squared, which is sine to the fourth. Okay. So any step around here makes sense, not make sense to you, because this one's was a little more difficult. Did I lose you along the way? Okay. Do you see how this was a dummy variable? We switched this guy, or this one right here, into W's just because we factored it. This became the factorization. We went back to cosine, so it's because that's what we're actually solving for or working with. This part was just fancy algebra, which got us to here, which is what we needed to get to sine squared. Sine squared is to the fourth. So the answer is going to be this, sine to the fourth. Okay, so all of this whole thing becomes this. This right-hand side, which is me trying to see if it factors nicely or not. And it did. So I decided to go this route. But as you can see, there's many things you can try, many paths you can take. I'm pretty sure there was another way to do this. Here, let me show you one actually. Yeah, I did this. I think last semester I took this approach. This might make more sense to you. I don't know. So can you guys see this example here? So this is the same question. I took a different path. So I said, you know what? Cosine to the fourth is cosine squared, which means I can switch this guy to 1 minus sine squared. And then I did the same for this cosine. I changed it into 1 minus sine squared. I expanded everything, multiplied everything out. Everything canceled out except sine to the fourth. I think this approach is more intuitive. The other approach I think was more fancy. But you see, at the end of the day, you're just trying to get there. Try whatever you like. Okay, if you try something and you feel like you overcomplicated the problem, or you're just stuck, then try something else. Start over. Okay. Does that make sense? But yeah, this is what I did in the spring. Today it did not come to me. I tried something else. Okay. Someone requested 20, right? You guys cool on 12 before I move on. Problem 12. Let's do 20 then. Five. Problem 20. So as soon as you see this, you see two fractions being added together, right? So that should be your big hint. Add the fractions and see what happens. Once you've added them, you should get some, maybe something squared or some sort of identity that you can apply. Okay. So do you agree that this denominator is prime? Right, well, you can't factor anything from 1 plus sine. So therefore it is prime. Cosine has, you can't do anything. It's just a cosine. It is also prime. So that means that the LCD is going to be just the product of these two. So introduce the LCD here and there. All right, so LCD is going to be this guy. So this one will need you to multiply by cosine over cosine to get the LCD. And this one will need 1 plus sine, the second fraction. Okay. I don't recommend that you multiply the denominators right away. The top part though, go ahead. Because it's possible that something will cancel once you apply an identity. Okay, so cosine times cosine, cosine squared. These two are just right there. 1 plus sine times 1 plus sine, well, that's just going to be 1 plus sine squared. It doesn't matter which part goes first. It is the same for the which factor goes first. I'm going to make them the same as these two. So now that you have the same denominator, you can add the numerators. So cosine squared x plus 1 plus sine squared over the LCD. So I've added the fractions. Okay, so again, like I said, this section or this chapter is going to assume that you're comfortable adding any kind of fraction. So make sure you practice. Okay. Because again, we're not solving for anything. You're trying to demonstrate you know how to simplify and get to the end, right? A simple statement. I think in the next section, we're going to prove a statement, but right now we're just practicing. So at this point, I don't see anything, any identity that I can use that's obvious. Nothing technically cancels right now, but I can probably square this piece here and see if that can help me. So that's the first thing that I'm thinking about is, let me do that first. Squaring these two terms, this binomial will get me 3 terms, right? There. Okay. So this first step right here is just add fractions. Nothing crazy. Then here to here, we just did some algebra. We multiplied out this term. Now, notice we have a cosine squared and a sine squared. They're both positive. I'll put them together so you can see it more obviously. What is sine squared plus cosine squared? Pythagorean is going to be equal to 1. So that piece will just be a 1. So that would be nice. So right here we get 1 plus 1 plus 2 sine x. So that's the Pythagorean. Okay. Now 1 plus 1 is obviously 2, which now gives us something to factor. All right, amount of space on this page. We'll continue in the next page. So far, are you guys still with me? This is one of the harder ones, I guess, but we got this. I hope. Okay. I'm gonna turn the page. So we're right here. I'm gonna factor 2. So we get 1 plus sine x on top. Then on the bottom, we have 1 plus sine x times cosine. So now that it is factored, you can cancel. Remember, only cancel things if everything is factored. We have a product up top, products on the bottom. That's the only time you can do this type of stuff. It has to be products. Okay, so now we're at here, 2 over cosine. Pretty much done. Just to make it more obvious to you, this is the same thing, right? As this. So what is 1 over cosine? What is the final step here? Hmm. Yeah, it's going to be secant. And that's it. We're done. 2 secant. So all that nonsense was just 2 secant. Does that make sense? Any of the steps confusing or strange? Do you see how it all kind of came about once you added the fractions? That first step allowed you to do all kinds of stuff. Okay, so that's it for 7-1. Unless you guys have some questions. Do you guys have any questions on chapter 6 or exam review or homework problem you're stuck on or concerned about, or 7.1? Let's take a 20-minute break. Then if you find some questions, we'll talk about it then at 1 o'clock.